This video is about assigning oxidation numbers to species in a compound and how to determine using oxidation numbers if a reaction is an oxidation reduction and which species is oxidized and which is reduced. So there are 6 simple rules for assigning oxidation numbers. These rules are listed on the screen. I'll run through them very quickly with an example. First of all, free elements are always assigned an oxidation state of 0. So something that's in its elemental state. And that means for diatomic elements like hydrogen, which is H2, or oxygen, O2, they would have an oxidation state of 0. Alkaline metals are always an oxidation state of +1, and alkaline earth metals are +2. Which is the same as the common charge for those two groups. Fluorine has an oxidation state of -1, always. Hydrogen can have an oxidation state of +1 when it's combined with a nonmetal, or -1 when it's combined with a metal, because we always know hydrogen has some unusual and special features. Oxygen is almost always a -1, except when it's with fluorine. Because oxygen is a -2, which is its common charge, unless it's combined with fluorine. And the most important rule is that the sum of all the oxidation states in the compound must equal the overall charge on the species. So if it's a neutral compound, all of the oxidation numbers must add up to 0. If it's a polyatomic ion, for example, like nitrate, which has a -1 charge, the oxidation state of all the atoms in the molecule have to add up to -1. All right, so let's look at some examples. This is a problem from Alex, similar to the one that you're going to work in class. So we're going to look at the highlighted species here. Now in the first one, we have a compound, a polyatomic ion with hydrogen, carbon, and oxygen. And the overall thing has a -1 charge. All right, so if we work backwards from our rules, the one that takes precedence here is oxygen. Oxygen is always a -2. So in this case, each oxygen atom has a -2 for a total of a -6. Okay, now the hydrogen is combined with non-metals, so it's going to be, a +1. Okay. So the oxygens are a total of -6. The hydrogen is a +1. So that means that the carbon is going to have to be +4 in this case, an oxidation state of +4, so that the overall sum of all the atoms is a -1. All right, what about the next one? Well, we have a hydronium ion. H3O+ is called hydronium. Again, oxygen is always a -2. Unless it's combined with fluorine. So in this case, the oxygen is going to be a -2. Well, what's the hydrogen going to be? Well, the overall ion has to have a +1 charge, and we know that hydrogen is usually a +1 when it's bonded with a nonmetal. So in this case, each hydrogen is a +1, which gives us an overall charge of +1 for the whole hydronium ion. All right, the next example is carbon with 1 hydrogen and 3 chlorines. Well, in this case, let's start with the chlorines. The chlorines have an oxidation state of -1. And hydrogen is always going to be +1 when it's with nonmetals. It's a neutral compound, so we have -3 from the 3 chlorines, +1 from the hydrogen. So that means that in this case, the carbon has an oxidation state of +2. That gives you an overall sum of 0 because it's a neutral compound. All right, the last one on our list is carbon dioxide, our common greenhouse gas. Carbon dioxide, well, oxygen's always -2. Unless it's with fluorine. So that means each oxygen has a -2 for a total of -4. And since the whole compound is neutral, the carbon has to be a +4 in this compound. All right, let's take another look at another problem here. We have The next question says, figure out if the highlighted atom is oxidized or reduced. Well, in order to answer this, we have to figure out what is the oxidation number of the atom as a reactant and what is it as a product. If the oxidation number goes up, then it's oxidized. If the oxidation number goes down, it's reduced. All right, so if we look at number 1, we have NH3. Well, in this case, hydrogen's always going to be a +1 when it's with a nonmetal. So there's 3 +1s. So that means that nitrogen has to be a -3 in ammonia. So it's starting as a -3 as a reactant. Well, let's figure out what it is as a product. Here it's in the nitric acid. Again, hydrogen, we start with the oxygen. Oxygen takes precedence here. So oxygen's a -2. There's 3 of them for a total of -6. And we have 1 hydrogen. The hydrogen's a +1 when it's with nonmetals. So that means that the nitrogen has to be a +5 in order to give you a neutral compound. So what do you think? Nitrogen went from +3 to +5. So in this case, it's being oxidized because the oxidation number increased. All right, we'll do one more. Number 2, this is the classic combination reaction between hydrogen and oxygen to make water. Oxygen is actually both the hydrogen and oxygen as reactants are zeros because they are in their elemental state. So if we start with oxygen as a 0, then what is it when it's in the water? Well, oxygen's always going to be a -2 unless it's bonded with fluorine. So in this case, the oxygen goes from 0 to -2. So that's a decrease in oxidation number. So oxygen's being reduced in this case. As a side note, oxygen, when you react with oxygen, oxygen usually oxidizes other things, so therefore it gets reduced itself.